Let's work on part 1, HTTP basic authentication. As you can see, here is the sequence diagram. In this video, we're going to focus on part 1, basic auth. First, let's create a feature branch for this authentication and authorization issue, and then bring in 2 necessary Spring security dependencies. Let me toggle over to IntelliJ. Git branch authentication authorization. Git switch Next, let's bring in 2 important Spring security dependencies. Let's go to Google Chrome. The first one is called Spring Boot Starter Security. Let's go to Maven repository and copy this. Make sure you include the starter when searching, not just Spring Security. And then go back to IntelliJ. Let's go to pom.xml. And right here, paste. And we can safely delete this version because the version is inherited from the parent POM. Okay. Also make sure you are not messing up the tags. So this dependency is inside the dependencies. So Spring Boot provides this spring-boot-starter-security starter that aggregates Spring security-related dependencies together. Now let's bring in the second one. Let's go to Chrome again. Maybe here. Let's search Spring Boot starter OAuth 2 resource server. It's right here. Copy. Paste. Let me reload. Let's briefly look at the 2 dependencies from the Maven panel. Okay, pay attention to this dependency. Spring Security OAuth 2 HOC. This dependency includes a Nimbus JWT library that supports encoding, decoding, and verifying JWTs. We'll use some classes from this dependency. By the way, Spring Boot Starter OAuth 2 resource server, this guy here, depends on Spring Security. So by bringing in this dependency, Spring Security will be brought in automatically. So actually, if I go here, I can safely delete this part, and there's no problem. So we don't really need to bring in Spring Boot Starter Security explicitly here. So one dependency is enough. But for information, I will keep it here. Next, let's launch our program. Here in the console, Spring Security created a password for us. I wonder when do I use that? All right, so let's go to Chrome and try to access one API endpoint. Localhost 8080 API v1 For example, artifacts. All right, now this time, I cannot see the list of artifacts. So by default, Spring Security will protect everything. Okay, then what is the username? Spring Security has created a default username called user. Then what about the password? Yes, I just saw that from the console. So let's go back here and copy this and put in here and click sign in. Okay, so now I get a list of artifacts. So let me explain what happened. Do you remember Spring Boot's auto configuration? By bringing in Spring Security dependency, Spring Boot enables its default configuration. That is, Spring Security requires an authenticated user for any interaction with the application. It protects everything. Spring Security generates a default login form for the application, like you just saw. Spring Security generates an in-memory user with a username of user and a password that is logged to the console to authenticate with form-based authentication and so on. There are other default features I don't cover here. Next, let's do this again. But this time, let me show you the network traffic. But before we do that, let me make sure I clear the cache. Okay. Do it again. So here, let me sign in. User and password is this, and click sign in. Okay, let's click this request. Scroll down. Pay attention to the cookie. Now the cookie has a JSession ID. And remember the last 4 characters, 571F. Okay, next. Let's request a different API endpoint. For example, wizards. Make sure you remember this JSession ID. I also put it on the screen. Press enter. Well, this is interesting because this time it's not redirecting me to the login form. In other words, I do not need to log in. I can get a list of wizards. What happened? So let's click this request and go all the way down to the request headers and look for this cookie. Look at here. This is the same cookie, or this is the same JSession ID, 571F. So what is this JSession ID? What happened behind the scenes is that the server created a session with this JSession ID. Once the user is authenticated, the session stores the login status of the user. Then the server sends a cookie with the session ID back to the browser. When the next request comes in with this cookie that has this JSession ID, even without username and password, the server knows this request is from an authenticated user. In other words, the server remembers you. And that is pretty handy. You log in once, then the server remembers you. We will come back to this JSession ID when we discuss the topic. Why should we use JSON Web Tokens? If you clear your cookie, just like what I did before, then you will have to log in again because the client side loses track of this JSession ID. Okay, so this is the default behavior of Spring Security without any configuration. And of course, we want to customize it. First, we want to secure some API endpoints, but also make some API endpoints public. Second, we don't want all users to share one username and one password. Recall that we have already saved some user credentials in the database. So let's go back to IntelliJ. Like here, we already saved 3 users in our H2 database. We need to let Spring Security access those credentials in the database for authentication and authorization. How do we tell Spring Security what do we want? The answer is configuration. Next, let's configure Spring Security to make it work in line with our requirements. Let's create a package. Let's call it security. We're going to put all the security-related classes in this package. Right-click. Let's create a new Java class. Let's call it security configuration. We're going to define our custom security rules and configurations in it. But first, we need to annotate it using @configuration. We will be using the base URL in this class, so let's inject that in. Private string base URL at value API.endpoint.base-URL. Now recall that the value of the base URL is stored in the application.yaml file on the resources. This one. Okay. Next, let's register a security filter chain bin by creating a method that returns a security filter chain instance. Public security filter chain, and we're going to pass in HTTP security. Let's call it HTTP. Let's expose it as a bin at bin, so it'll be taken care of by Spring. Inside this security filter chain method, we will return a security filter chain instance. The way we do that is called builder pattern, which is one of the design patterns. So return http.build. Okay, make sure we handle this exception. All right. Next, let's define this builder to customize the Spring Security for our application. By default, Spring Security authenticates everything. Here, we are overriding the defaults. We can say, authenticate this API endpoint, that API endpoint, and don't authenticate this, and so on. And here is the syntax. Now, recall that no authentication is needed to find all artifacts or find an artifact by ID. So, dot authorize HTTP requests. And inside, we're going to pass in a lambda. It's called authorize HTTP requests. Dot requestMatchers. It's getting pretty long here, so let me break the line here. So first, we're going to pass an HTTP method. HTTP method.get. Next is a pattern. This dot base URL plus slash artifacts, then wildcard. Dot permitAll. Okay. Line 21 means if an API endpoint is an HTTP GET request and it matches this pattern, that is, if the URL starts with /API/v1, that is in this dot base URL, /artifacts, then no authentication is needed. Permit all. Okay. Next, For user management component, requestMatchers, HTTP GET, this dot base URL plus users wildcard. Recall that only users with the admin role can perform this operation. So there is a method called dot has authority role underscore admin. So this is the naming convention. It always starts with this prefix role, all caps, underscore, and then followed by the role name. So here we're protecting this endpoint. Okay, then let me copy and paste. Okay, so here is post, but this time we're going to get rid of the wildcard because the login API is also a post request that starts with /users. We want to exclude it from this security rule on line 23. Then here is put, and here is delete. Okay, so far so good. Since we will use H2 console during development, we should also make H2 console public. Dot requestMatchers, and here is a little bit tricky, and pathRequestMatcher dot AntMatcher, and here we're going to pass in the pattern, which is /h2 console /wildcard dot permitAll. And this is not enough for H2. We have to add one more line here. Dot headers dot frameOptions dot disable. So to make sure you can access H2 console when Spring Security is on, you have to add line 26 and line 28. Otherwise, you won't be able to see the content in H2 console. So let me add a comment here. This is for H2 browser console access. Okay, let's go back in here. Line 21 to line 26, we explicitly defined many security rules or authorization rules. For everything else, we need them to be authenticated. So here is dot any request dot authenticated. So always a good idea to put this as last. For example, here we didn't mention anything about Wizard API endpoints. Then line 27 will apply to Wizard API endpoints. We can add a comment here, say disallow everything else. Okay, so here disallow means they need to be authenticated. It's not public. Okay. So here is a quick summary. In security filter chain method, we defined several security rules or authorization rules. A user can find all artifacts or find an artifact by ID without login or without authentication. That's line 21. A user can also access H2 console without logging in or authentication. Everything else needs authentication. And even more, if we're trying to access user API endpoints like get, post, put, and delete, not only the user needs to be authenticated, the user also needs to be authorized. a user has to have the role admin to perform those operations. That's line 22 to line 25. Sprint Security will intercept an incoming request and check who sends it. If you are a normal user and you're trying to access those user API endpoints, then you will be denied access to it. A 403 error, forbidden, will be returned as a response. Pay attention to line 23. This pattern doesn't have a wildcard. This is because the login API endpoint is also a POST request, and its URL also starts with /users, and we're trying to exclude it from this rule. So line 23 only applies to add a user, not to login a user. Login user API endpoint needs to be authenticated, but it does not need any authority. Okay, in the end, we need to come down here. Also disable CSRF. CSRF stands for Cross-Site Request-Forgery. By default, it is on, and we need to turn it off in this project. Otherwise, there will be a problem if you are trying to send a POST or PUT request to the server. You will get a 401 error. So we need to turn it off. Next, let's run the application and test some endpoints that do not need to be authenticated. Let me toggle over to Chrome. I have already cleared the cookies, so this is a fresh start. Localhost 8080 API v1 artifacts. Okay, as you can see, I do not need to log in to access find all artifacts. What about wizards? Now remember, we do need to be authenticated to access all the wizards. Now this time, access to localhost was denied. You probably wonder why we are not redirected to the login form. This is because once our security configuration kicks in, the default form login is turned off. Not big deal, because later on, we're going to implement basic login. We're not using form login. Okay, so let's go back to IntelliJ. There is one thing we need to do before implementing the HTTP basic authentication. Recall that in a previous video, I said it is a bad practice to save plain text passwords in the database. As you can see here, now we're saving plain text passwords directly in the database, which is a bad practice. Sprint Security provides several good password encoders or encryptors. The most popular one is called bcrypt password encoder. Bcrypt is a one-way password hashing function. One-way means once the password is encrypted, it is computationally difficult to invert. So let's create one here so we can use that encoder to encrypt our plain text passwords before we save them into the database. It is actually pretty easy. Let's go back to security configuration class. Public password encoder. And here we're going to return an instance of bcrypt password encoder. The constructor is requiring an integer called strength. So here we're going to pass 12 to it. And don't forget to expose it as a bin so Sprint can inject it into whoever needs it. So what is this strength? So let's click into this constructor and see the source code. The parameter strength means the log rounds to use. And usually it is between 4 and 31. The bigger the number, the more robust and secure your encoded password is. Now in our case, we passed 12. So that means that will be 2 to the 12 hashing iterations. You probably ask me, why not use a strings of 31 or close? That will make our encryption very slow and not usable. So I think 12 is really a good number. So here, let me briefly explain how bcrypt algorithm works. In this algorithm, the plaintext password to be encoded goes through the following steps. The plaintext password is first sorted, which means a random sequence of characters is added to it. This is very critical. The password is then hashed. The hashing process keeps iterating itself for the specified number of rounds. That is the strength, 2 to the 12 rounds, or 4096 rounds. So this is a pretty robust and secure password encoder. Next, let's use this encoder to encode our plaintext passwords before we save them into the database. And we're going to do that inside the user service. So first, let's inject the encoder in. Password encoder, password encoder. Add constructor parameter. Then let's go here and find save. As you can see here, we have a to-do. We need to encode plain text password before saving to the database. Okay, so new Hogwarts user dot set password. This dot password encoder dot encode the original plain text password dot get password. Okay, so here we're getting the plain text password, pass it to encode, and this encode returns the encrypted password. Then we set it back to the password to override the original plain text password. And then on line 36, we save new Hogwarts user into database because at this time, the password is already encrypted. Okay, then let's go to DB data initializer. Now this time, instead of using UserRepository, we're going to use UserService. Okay, so scroll all the way down. Because the logic to encode password is in UserService, not in UserRepository. So that's why here we're using UserService to save user 1, user 2, and user 3. Okay, so it looks good. Let's run the application again. And then we're going to check the H2 database to see whether we have successfully encoded and saved all the passwords. All right, it's up. Let's go to Chrome. Localhost 8080 H2 console. Okay, it's there. Connect. And let's find all Hogwarts users. As you can see now, the encoded passwords are stored instead of the plain text passwords. And this is considered as a good practice. At this moment, you probably have this question. If bcrypt is a one-way hashing algorithm or one-way encryption algorithm, then how does Spring Security compare the submitted plain text password with this encrypted password in database? Well, it turns out that when you log in, Spring Security will first encode your submitted password using the same password encoder, and then compare the encoded submitted password with the stored ground truth encoded password. So Spring Security is comparing the encoded passwords rather than plain text passwords, and that's pretty mouthful. So now we're ready to implement the HTTP basic authentication process. Let me toggle over to the slides. Here is the sequence diagram again. When an HTTP request with username and password comes to the server, a filter in the security filter chain will capture this request and pass it to an authentication provider. There are different kinds of providers. This provider will use UserService and UserRepository to retrieve the correct user credentials from the database, and then compare with the submitted credentials. Of course, the provider will first encrypt the submitted password and then compare. So the provider is not comparing the plain text passwords, but the encrypted ones. If they match, a principal will be created. In Spring Security, a principal represents a logged-in user. So what is this HTTP basic authentication? Let's briefly talk about it. HTTP basic authentication is a client authentication method built into the HTTP protocol that allows a client to provide a username and password to the server when accessing secure resources over HTTP. When requesting a protected resource, the client sends HTTP requests with an authorization header that contains the word basic, followed by a space and a base 64 encoded username:password string. For example, John:123456. For the above credential, the authorization request header will be basic, space, and here is the base 64 encoded John:123456. I want to point out that even though the user credential is encoded here, it is not encrypted. So this is different from bcrypt. So this encoding can be easily decoded by packet sniffers. So remember, for security reasons, the basic authentication method should only be used over secure HTTPS connections. So let me show you what a basic authentication looks like in an HTTP request. In this case, I'm going to use my command line to make an HTTP request. Here, I'm going to use curl, which stands for client URL. It's a command line tool that developers use to transfer data to a server. I'm going to make a post request to HTTP localhost 8080 API v1 users login. So this is the login API endpoint. Then how do I attach username and password with this request? Here is the syntax. -u John:123456. To show you more details, I'm going to add this -v variables to show you the detailed request and also the response. Okay, make sure at this moment your Spring Boot application is running on port 8080. So press enter. Here we got some detailed information about request and response. In the request, take a look at a header called authorization. And the value is basic space, and that's the base 64 encoded John:123456. And of course, here for the response, we get 43 because we haven't enabled HTTP basic authentication in Spring Security. That's okay. Now that you have a basic understanding of HTTP basic authentication, let's work on implementing it in Spring Security. This HTTP basic authentication process is very simple. Then what should we do? Since the provider delegates the task of retrieving Hogwarts user credentials to this service bin, we need to modify this user service class and also use a repository interface to make sure they can facilitate the Spring Security authentication provider to find a user in the database. Let's toggle over to IntelliJ. To make sure the user service can work with the authentication provider, we need to have this class implement an interface provided by Spring Security. It is called UserDetailsService. As you can see, this interface is from Spring Framework.security. So let's take a look at this interface. UserDetailsService is a core interface which loads user-specific data. It is used throughout the framework as a user DAO. DAO stands for Data Access Object, so think of it as the repository, and is the strategy used by DAO authentication provider. Yes. So actually, the authentication provider we're using in this case is called DAO authentication provider. It needs access to the data. There's only one method in this interface. It's called load user by username. We need to implement this in user service. So go ahead and implement the unimplemented methods, which is load user by username. Click OK. Okay. So as a developer, you only need to define this method. And this load user by username will get called by the authentication provider or by the DAO authentication provider at some point. And you don't have to worry about authenticating passwords because that is done by the authentication provider. And this user service bin will actually be injected into the authentication provider so that the authentication provider can use it to load user information. Okay, then how do we load user by username? Or how do we find a user by username? Now, of course, we have to depend on repository object. So we can write this dot UserRepository dot, maybe called find by user. Well, guess what? There's only find by ID. There's no find by username. Then what should we do? We're stuck. Because unfortunately, at this moment, the user repository only supports the basic CRUD, that is, find by ID. There's no find by username. What should we do? So let's go to user repository. Here, we want user repository to help us find a user by username. Can we define our own custom queries? The answer is yes. Let me show you how to do it. Find by user name. So we're using the same naming convention, find by something. And we're going to pass in the username. Since this is an interface, you don't have to provide any implementation. Then what should be the return type? You probably want to use Hogwarts user. Okay, that's fine. But do you remember the return type of find by ID? So let's go there. Find by ID returns an optional, which wraps the Hogwarts user. Why? Because it is possible that this find by ID cannot find anything, right? In that case, it will return an empty optional. So if you do not want to use if-else to perform null checks, then it is better to return an optional instead of a Hogwarts user directly. So let's go back and cut optional Hogwarts user. So basically, if found, this Hogwarts user is wrapped in an optional object. If not found, it is just an empty optional and will help make our code look more concise. And that's it. Your job is done. Then you're like, we only defined an interface method, a method doesn't have a body. Then who will provide implementation for this interface method? You're right, Sprint Data JPA. But how? How does Sprint Data JPA know that I want to use this method to find a user by username? It is because we're following the naming convention, find by plus the name of a field. So let's go to Hogwarts user class. So if you want to define your own custom query and take advantage of Sprint Data JPA, then you better follow the naming convention. Find by ID, make sure I is capital. Find by username, make sure U is capital, or find by password, which is really stupid, don't do it. But you can also do find by enabled, for example. Make sure this part must match the name of the field you define in Hogwarts user class. Same thing here. So that's the naming convention. So in this case, we can do something like this. Boolean enabled. And this one will return a list of Hogwarts users that are enabled or disabled, depending on the value in this Boolean formal parameter. Okay, so here we don't need it, so let me get rid of it. Now, what if I want to find by two fields? For example, I want to find by username and password. Okay, simple. Find by, then the first field name and the second field name. Now here, of course, you should pass username and password. And of course, we're going to copy this and paste it here. So this method corresponds to this SQL. Spring Data JPA will help us convert this interface method into this SQL. This feature is called derived query methods. Below this video, I included a link to the official documentation that explains derived query methods and also the naming conventions. I highly recommend you read the documentation. Okay, so let's get rid of this. We don't need it here. Let's go back to user service. So this time we can do something like this. This dot UserRepository dot find by username, then pass username to it. Now here, there are two problems to be solved. Problem one, load user by username. This method is not returning a Hogwarts user, but a user details. So if you take a look at user details, this is an interface from Spring Framework.security. It provides core user information. They simply store user information, which is later encapsulated into authentication objects. Then what should we do? Apparently, we cannot just return this Hogwarts user. So we have to somehow convert a Hogwarts user into user details, which is expected by the authentication provider. Now, this is a perfect situation that we can apply a design pattern called adapter pattern to solve this problem. What I'm going to do is, under package Hogwarts user, let me create an adapter class called my user principal, and have this class implement the required interface. That is the return type of load user by username method, user details. And of course, here we have to make it happy by implementing all the interface methods. Click OK. Wow, there are a lot, right? We got get authorities, get password, username, is the account now expired, and so on and so forth. Click OK. And we can use this adapter class to wrap the Hogwarts user instance returned by UserRepository. Let's create a constructor. Let's also create a getter for this Hogwarts user. Because later on, we're going to use this user. We want to get it from this principal object. Okay, then let's go back to user service. Find by username. If found, we're going to map it. Hogwarts user, this is the found Hogwarts user. We're going to map it to an instance of my user principal. I'm going to pass this Hogwarts user to it. Otherwise, or else throw, with throw and username not found exception. As you can see here, we already have this in the signature of this method. So throw new username not found exception. Then I'm going to pass in the error message. Username is not found. Okay, and here we can just return this long statement. All right, let me add some comments here. First, we need to find this user from database. If found, wrap the returned user instance in a my user principal instance. Otherwise, throw an exception. Okay, so pretty straightforward. Instead of returning the Hogwarts user directly, we're going to first convert it into my user principal, which implements this user details interface. So the authentication provider will be happy because the authentication provider is expecting not a Hogwarts user, but something that implements user details interface. So we're doing good. Otherwise, we'll stop and just throw exception. So we'll talk about how to handle this exception later on. So right now, there's no way to handle this exception. Okay, so let's go back to my user principal and we need to implement this class. So it's not complaining, that means there's no compile error, but the logic here is not correct. So what happened here is, think of this user details interface as a contract between developers and the Spring Security framework. Spring Security says, okay, I'm happy to help you authenticate users, but it is your responsibility. That is, it is the developer's responsibility to encapsulate the returned user into a class that implements user details, because Spring Security is expecting it. Spring Security does not know your user class. Like in this case, it doesn't know Hogwarts user. It only recognizes user details, which is the interface provided by itself. So simply put, later on, the authentication provider will use the methods defined in user details interface to obtain user information and credentials. So now let's override those methods one by one and return the correct information to the provider. So here, let's do this in the end. First, return password. Okay. And the password is stored in this .hogwartsuser.getPassword. Okay, it's from here. Username is stored here as well. This .hogwartsuser.getUsername. We don't have account non-expired, so here we're going to make it true. Same thing here. We don't have account non-locked, so we have to make it true and make it true here. Okay. Now, if in your project you are considering account expiration, locked, or so on and so forth, make sure you program in your user class and here return them. In this case, we just make them return true, and you have to make them return true, otherwise authentication will fail, even if we have the correct login credential. Oh, we do have is enabled. So here, this .hogwartsuser is enabled. Okay. What about authorities? Recall that each Hogwarts user has a field called rows. It is a space-separated string. For example, admin space user. So here we need to split this string by space and convert each string into something called granted authority object, because the authentication provider is expecting a collection of granted authorities. So for example, for John, if you recall John's account, then John has two authorities, admin and user. So here we should return a list with two granted authorities. One is admin and the other one is user. And here is how we do that. String utils dot tokenize to string array. Because remember, the rows is a space-separated string. So here we first convert that into an array of strings. So we're using this method. This dot Hogwarts user.get rows. So this returns a space-separated string. And we want to split by space. And then for each string in this array, we're going to convert it into a granted authority object. So first, let's convert this string array into streams. Arrays.stream, we're using Java 8 Stream API. Okay, and paste. So this syntax will convert this string array into stream. Then we can use the stream APIs. Here, dot map. We're going to map each string, like admin, a user, into an instance of granted authority. So here, let's call this a row, pass a lambda, new, call it simple granted authority, which is a subclass of granted authority. And by convention, as I said before, we usually add this prefix, row, all caps, underscore, in front of the row. Okay, so we're going to have row underscore admin or row underscore user. And we pass that to the constructor, simple granted authority. Finally, let's put them in a list. And this is enough to list. Convert them to a list because this guy here is expecting a collection of granted authorities. Okay. And here, let me add some comments. Copy and paste. So feel free to pause the video and read the comments. Okay, that's all for the My User Principal class. Let's come back to user service and solve the second problem, which is we need to properly handle this username not found exception. So how do we handle exceptions in Spring Boot? Think about it. We have done it several times. When we cannot find an artifact, a wizard, or a user. That's right. We need to go to the controller advice. So let's go here, system, exception, and exception handler advice. So we annotate it as REST controller advice. So let me copy this first and scroll down and add another handler method to handle the exception. Okay, so let's call this handle authentication exception, because there are different kinds of authentication exceptions. For example, user not found or bad credentials and so on and so forth. So we just want this method to handle all of them. And apparently here we should add many exceptions. So we'll put in a curly braces. Username not found exception is one of them. Also, we have bad credentials exception. That is when the password is wrong. Okay, the user is there, but the password is wrong. So they're really different. Right? So this means user doesn't exist. The username you provided is bad. But this one means the username is correct, the password is bad. And apparently here we should return something else. So this should be HTTP status dot unauthorized. I must complain about this name. I know this should be unauthenticated, right? But unfortunately, HTTP standard says you have to use this word unauthorized to mean unauthenticated, which is very confusing. And here, let's make this exception very general. Just call it exception. And here, we're using our own status code. So don't confuse them. This is the status code we defined by ourselves. Dot. We also called unauthorized for 1. And this time, we're also going to provide a message. Username or password. We don't really want to specify which one is wrong. Is incorrect. Okay, again, I said I want to complain about the name HTTP status.unauthorized, which really means unauthenticated. A 401 unauthorized response should be used for missing or bad authentication, and a 403 forbidden response should be used afterwards when the user is authenticated but isn't authorized to perform the requested operation on the given resource. Last but not least, let's go back to the security configuration class. And enable HTTP basic authentication in this security filter chain builder so that Spring Security knows that the client is using HTTP basic authentication. So it's very simple. Just right before build, just keep chaining those methods. .http basic. And here we have to pass some customizer, and let's write Customizer.withDefaults. And that's it. We're done with part 1. Here is a quick summary. What we just did in IntelliJ is we modified UserService class, UserRepository, and we added a new class, myUserPrincipal. In UserService, we have this class implement an interface called UserDetailsService, provided by Spring Security. This is the contract between our application and the Spring Security framework. We need to implement a method called loadUser_by_username. In this method, we use UserRepository to find this user by username. There, we defined a derived query method called findByUsername. UserRepository then returns the found Hogwarts user to the user service as an optional. But before the user service returns the Hogwarts user to the authentication provider, we need to convert it to a UserDetails object. And we applied the adapter pattern by wrapping the adaptee, which is the Hogwarts user, in an adapter object called myUserPrincipal. If UserRepository cannot find this Hogwarts user by username, then UserService will throw a username not found exception, and we need to properly handle it in the exception handler advice class. Then our job is done. What happened afterwards is that the authentication provider, and to be more specific, DAO authentication provider, will then compare the submitted password with the real password in this myUserPrincipal object. What really happened is that the authentication provider will first encode the submitted password and then compare the encoded submitted password with the real encoded password in this myUserPrincipal object. We, as the developers, do not have to work on the authentication details. We just need to retrieve the real Hogwarts user's credential from the database. So let's test if this works. So let me launch the program again. I'm going to show you how to use Postman, web browser, and command line to test this. So first, let's go to Postman. Here, I want to access this secured API endpoint, wizards. I'm trying to find all wizards. Then how do I do basic authentication using Postman? Because at this moment, if you click send, so here we got 401 unauthorized, but it should really be unauthenticated. The question is, how do we perform basic authentication using Postman? And it is under authorization, right? Click here. And the type, as you can see, there are actually different ways to authenticate. Okay? And so here, we're going to pick basic auth. And here, we're going to use John and 1, 2, 3, 4, 5, 6. And click send. There you go. It looks like our basic authentication is working. Let's keep testing. Maybe add a wizard. So same thing here. Basic auth. So John 1, 2, 3, 4, 5, 6. And this time we're adding a new wizard. Send. Now it works. Next, let's go to browser, and I will show you how to perform basic authentication using browser. So let's access localhost 8080 API v1 wizards. So as you know, this is a protected API endpoint, so I need login. So press enter. So in this case, HTTP basic authentication will open a prompt in the browser asking for username and password. So this time, let's try a different user, Eric. And the password is 654321. Press enter. And Eric can access all the wizards. Next, let me show you how to do this in command line. You have already seen that. Curl. And if you're making a GET request, you don't have to use -x. Just curl HTTP localhost 8080 API v1 wizards -u, for example, John 1, 2, 3, 4, 5, 6, and to show more information here. Okay, so press enter. As you can see, we got flag true, code 200, message, find all success, and so on and so forth. So this is the request, and this is the response details. Okay, finally, part 1 is done. In the next video, let's work on generating a JWT. See you in the next video.